Think about the last time you opened Instagram and scrolled past 100 posts, or browsed through thousands of restaurants on Swiggy. There isn't a programmer sitting in a cubicle typing out a separate block of code to load every single one of those posts or menus. YouTube hosts millions of videos. They don't have an army of engineers manually programming the display of every new thumbnail each day. Imagine you're stuck in detention, and the teacher hands you a piece of chalk with a punishment. Write the sentence, "I will become an AI engineer," on the board exactly 100 times. After the 5th time, you're bored. By the 10th time, you're getting frustrated. Getting to 100 is pure physical and mental exhaustion. Our hands and brains are simply not built to execute the exact same task over and over again without breaking down. But if you give a computer that exact same instruction, even if you ask it to write that sentence 100,000 times, it will execute it instantly. 0 complaints, 0 excuses, and 0 fatigue. Computers were engineered specifically for this kind of relentless repetition. To harness that computational stamina, we use a concept called a loop. They use a single piece of logic to process all of it, a loop. It allows you to automate tasks that would otherwise require dozens or even hundreds of repetitive lines of code. Let's run a practical experiment. Open your Python editor and type the command to print the phrase, "Hello, Moa." Now copy and paste that exact same line 4 more times, so you have 5 individual lines of code. Run that code. You'll see the greeting printed exactly 5 times in your output console. The code works. Now, how would you handle a request from your boss to print that exact same greeting 100 times? Writing 100 separate print statements by hand is an inefficient approach. It's difficult to read, hard to maintain, and creates unnecessary work. Manual coding fails the moment you need to scale. Instead of typing an action out 100 times, we need a way to type the instruction once and tell the computer how many times to repeat it. The immediate scalable solution is the for loop. Go ahead and delete those 5 manual print lines from your editor. Look at your screen. You only need 2 lines of code to do this properly. First, type for I in range 5. Then hit enter, and on the next line, type print hello Mawa. Before you run this, check your syntax. A common mistake for beginners is missing the colon at the very end of the first line. That colon is mandatory. It tells Python that the code inside your loop is about to follow. Next, look at your print statement. It must be indented. That empty space before the word print is how Python knows which instructions are actually part of the loop. Hit run. You will see 5 identical outputs in your console, executed exactly as before, but with much less effort. By writing these 2 lines of code, you have separated the instruction itself from the volume of repetition. You can now change that 5 to any number to scale your work instantly. This setup relies on precise logic. To understand how the computer reads this, we need to break the top line down into 3 specific functional parts. First is the word for. This acts as a trigger that tells Python to start a repetition sequence. Second is the letter I. This is a temporary counter. It's a variable that tracks exactly which repetition the loop is currently running. Third is the range function. Since Python uses 0 indexing, it fulfills a request for 5 loops by counting 0, 1, 2, 3, and then 4. Mastering these 3 components allows you to define exact boundaries for the machine. You tell it when to start, how to count, and exactly when the task is complete. Now it's time for a practice challenge. Write a loop from scratch that prints the phrase "I love Python" exactly 10 times. Step away from this tutorial, pause the video right now, and execute the code in your own editor. Welcome back. Here is the correct syntax for the challenge. You need for I in range 10, followed by an indented print "I love Python." If your console printed the phrase 10 times, you've correctly applied the syntax. You have replaced 10 individual manual commands with just 2 lines of logic. Successfully executing this challenge means you have moved from manual entry to using logic-based automation. You're now using code to handle the volume for you. You have now learned the core mechanics of repeating a text command. You've seen how this framework handles repetitive tasks efficiently, keeping your code clean regardless of how many times you need a task to run. We've used the counter I just to track repetition so far, but in the next lesson, we'll use the value of I itself to perform calculations and manipulate data as the loop runs. Secure your code from today.
Loops are a fundamental building block you will use in almost every program you write from here on out.
Loops are the underlying engine of infinite automation. They drive everything from the feed of a basic social app to the processing pipelines of global AI systems. Open your preferred Python coding environment. That could be VS Code, PyCharm, or a browser-based compiler like Google Colab. By the end of this session, you will build 3 functional Python automation scripts completely from scratch. With your editor open, you're now ready to write instructions that perform thousands of repetitions in the time it takes to type a single line. Start by typing the word for, the letter I, the word in, and then range 111. This split screen shows code and output. Type print I to get numbers 1 to 10. Look at the colon. Forgetting it breaks the engine. Notice we typed 11, but the list ends at 10. Python's range stops just before the second number. Pause here for a second. How would you modify this code to print exactly 1 through 50? To reach 50, you simply change the second number in your range bracket to 51. You just replaced 50 individual print commands with exactly 2 lines of code. Step 2. Let's bring a variable into the environment. Above your loop, define a new variable called num and set it equal to 5. Multiply that variable by I. The terminal calculates a perfect multiplication cable for 5. Change that input to 129, and the loop instantly recalculates a massive list of multiples. Adjusting that one variable instantly updates the entire list, demonstrating how a small change in logic ripples through an automated process. Clear your board. We are going to write a completely new loop designed to count backward from 10 to 0. Look at the updated code interface. Notice the third parameter we added inside the brackets. This -1 tells Python to step backward instead of forward. Print I inside, and at the bottom, print rocket launch. Accidentally indenting that final message outputs rocket launch 10 times mixed into the countdown. Remove the space to outdent. The output cleans up to a perfect countdown, finishing with 1 launch message. Indentation is Python's definitive boundary wall. It separates exactly what belongs inside your loop from the rest of your program. Let's look at the most direct way to repeat an action. Provide only a single number to the range command. Here we have for I in range 20. Inside this loop, command the engine to print the text, "Good morning." The terminal floods instantly with a wall of 20 identical messages. This brute force repetition is how you would build a script to annoyingly spam a friend's phone. Don't actually do that, though. Using a single integer tells Python exactly how many times to repeat the action, without needing to define specific start or stop points. Take a second to look at the 3 distinct scripts you just built. Loops exist to eliminate repetitive human effort. The time-saving logic you use today is the same mechanism that allows Google to deliver billions of search results without relying on manual labor. This checklist shows your 5 final challenges. You need to print your name 20 times, print 1 to 100, print even numbers, build a multiplication table, and create a countdown. Build all 5 on your own and post Day 5 complete in the comments once you've finished. Completing these tasks means you can now apply Python loops to handle repetitive work that used to take manual effort.